Hello, my friend. Welcome to my channel. So today I'm going to discuss about the testing, the difference between two means. Here, two samples are dependent. So let's see the example. A composition teacher wishes to see whether a new grammar program will reduce the number of grammatical errors her students make when writing a two-page essay. At alpha equals 0.025, can it be concluded that the number of errors has been reduced? So this is the data. We have 6 students here. Errors before for each student and errors after for each student. So in this kind of problems, we are looking at the difference distribution, because these two errors before and errors after, those data are dependent, because these two data are coming from the same person, the same student. So that's why these two distributions are dependent, right? In this case, we are consider the difference distribution, which is D. So you can calculate D. Let's take X1 is my errors before and X2 is errors after. So distribution, the difference of this distribution is X1 minus X2. We need to find all the data, which is D values for these two distributions. And then we can make the hypothesized testing for this. So I'm going to draw a chart here. The first one is X1 values and X2 values. And then the difference, which is X1 minus X2. Right? And I'm going to write down X1 values, 12, 9, 0, 5, 4, and 3. And all the X2 values, 9, 6, 1, 3, 2, 3. And then difference is X1 minus X2. So 12 minus 9 is 3. 9 minus 6 is 3. 0 minus 1 is negative 1. 5 minus 3 is 2. 4 minus 2 is 2. 3 minus 3 is 0. So this is the difference. Okay, let's write down the hypothesized testing, the null hypothesis and the alternative hypothesis. So here we are looking at this distribution, right? We are looking at this distribution. So we are going to find mean of this data, right? So then population mean represents mu of the difference, mu D equal 0. So here we are talking about a difference. So difference can be 0. In this case, alternative hypothesis, here the teacher wishes to see program will reduce the number of grammatical errors. That means your x2 should be small, right? This is large. So large number minus small number, you get a positive number, right? You get positive number. This is larger than 0. So your alternative hypothesis here greater than 0. So this is the claim. We are going to see if this grammar program is effective here, right? If it is effective, then x2 value should be smaller than the x1 values. So that means we are looking at the difference of mean greater than 0. Okay. So this is the hypothesis, and then let's look at the test statistic for this test. So as you can see here, we don't know about population standard deviations. So we are going to use t-scores. Here, t-naught, the t-score is calculated by the sample mean. Here the sample is the difference distribution, right? D bar represents the mean of the differences minus hypothesized value mu d, and standard deviation of differences divided by the sample size square root. So we are going to calculate this D bar and SD. To calculate this one, we need this number. We need to calculate D square, which is x1 minus x2 square. So we are going to calculate that number. So since D, which is x1 minus x2 is these numbers, right? So we are going to take the square of 3 square is 9, 3 square is 9, negative 1 square, which is 1, 2 square, 4, 2 square is 4, and 0 square is 0. And you know D bar, so D bar is the summation of the all data values divided by the sample size. That's how we calculate the mean, right? So all D values are there. So summation of D is you are adding all these numbers. 3 plus 3, 9. 9 minus 1 is like, so 3 plus 3 plus negative 1 plus 2 plus 2 plus 0 divided by sample size is here 6. So that means this value is 3 plus 3 is 9. 9 minus 1 is 8. Sorry, 3 plus 3 is 6. 6 minus 1 is 5. 5 plus 4 is 9. 9 over 6, which is 3 over 2, 1.5. So D bar is 1.5. The summation of all these numbers here is 9. Okay. And then SD. Let's look at the formula for SD. You can use this formula. There are two formulas to calculate the standard deviation of a sample. So I'm going to use this formula. It is n times summation of D square minus summation of D whole square divided by n times n minus 1. So this is the formula I'm going to use to calculate the standard deviation of the differences. N is 6 and summation of D square, summation of the square of differences. So this is the D square column. So we need to take the summation of all these numbers. Summation of D square. So this is, as you can see, 27, right? And summation of D square is 27 minus sum of D. Sum of D is 9. So 9 and take the square divided by sample size is 6 and 6 minus 1 here. So if you simplify this one, it is 162 minus 81 divided by 30. So this value is 1.64. So the standard deviation of the differences is 1.64. Now we can calculate T naught. T naught value is D bar is 1.5 minus mu D equals 0 divided by standard deviation SD is 1.64 divided by square root of 6. The value of this number is 2.24. So this is the test statistic value for this problem. So as you can see, this is a right tail test. According to the alternative hypothesis, this is a right tail test. So it is a right tail test. I'm going to use critical value method. So here alpha is 0.025. That is, so we are in the t distribution. So this area is 0.025, right? We need to calculate this critical value over here. To find that, you need to look at the T table. T table, degrees of freedom. Here sample size is 6. So degrees of freedom is n-1, which is 6 minus 1, which is 5. Look at the degrees of freedom 5. And then look at one tail. One tail 0.025. And you will see a number in the table, which is 2.571. So this is the critical value. This critical value is 2.571. So according to critical value, you compare your test statistic value, right? As you can see, 2.24 is less than 2.571, right? That is, it falls in the non-critical region. 2.24 is or somewhere around here. Because this cutoff value is 2.571. 2.24 is less than 2.571. So it's in the non-critical region. So the decision is we fail to reject the null, which is H null. So here we fail to reject the null. If you fail to reject the null, then the conclusion is there is not enough evidence to support the claim. Claim, what is the claim here? Claim that the number of errors has been reduced. So there is not enough evidence to support the claim that the number of errors has been reduced. Right? So that's the conclusion of this test. So we have no enough evidence. So we are going to assume that difference is 0. There is no effect of this grammar program on the grammatical errors of the students. So that's the conclusion. So there is no any difference. So it is the grammar program is not effective in this case, because we don't have enough evidence to prove that the grammar program is effective in this case. So I hope you understand this hypothesis testing for two means under dependent samples. So if you have any questions or concern, please comment, and thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.